Hello, hi, I'm Alp, and I'll present to you today our project Gamayun of Translators Without Borders, where we use language technology, especially machine translation, to improve humanitarian communication. So I hope you enjoy it. I will start with showing you a map, which is relevant to everyone in the world right now. The rise of COVID-19 cases throughout the world and the linguistic diversity in each country, which is the latter one, the number of languages in a country is shown with the darkness of a country. So this shows the importance of delivering life-saving information to the people in the languages that they understand. The sources of information in a pandemic like this, the COVID-19 pandemic, the sources of information are usually in a handful of languages. Let's say English, Chinese, French. But the thing is, in order to treat this pandemic in a global scale, we need everyone's understanding and everyone's action. But how do you get that information easily to the speakers of 7,000 languages of the world in a way that they understand? This is a really, really difficult task. And this is much harder in the languages of marginalized populations, which are basically people speaking languages which are politically or geographically left behind and are really disadvantaged in terms of linguistic resources, language technology, and all sorts of machine translation and speech recognition, which right now helps a lot in the diffusion of information, especially for translation, right? So what we see for the speakers of marginalized languages is that they are left behind hugely. They're in terms of humanitarian reach. There are over 177 million people in need of humanitarian assistance, and they speak over 3,000 different languages. Most of them are left behind a wall, a language barrier, and they are left invisible because of the languages that they speak. It's because the humanitarian assistance, the aid that we're trying to send, is not in their language, and the lack of resources really hinder a lot the reach. So the information doesn't flow easily, and the information we're speaking about right now is life-saving information, and they can't voice their needs either. So with Gamayun, we have focused on how to bring language technology in languages that are of humanitarian context. What are these languages? In the initial focus, we are focusing on Levantine Arabic, Kurmanji, Tigrinya, Rohingya, Swahili, Hausa, and Kanuri. These are languages that are really relevant to this workshop, since they are either low resource or even zero resource in some of the cases. So in Translators Without Borders, we are developing machine translation for these languages in order to assist the translators of these languages. These translators are hard to find, and they are also really disadvantaged in terms of, as I said, tools like dictionaries to machine translation services. So the areas that we seek impact can be summarized in three main areas. First, for languages that lack data, make data. That's definitely the first most important step. As much as there are low resource methodologies and also going around, we need to get data for these languages in order to start developing technology. Second comes the actual development of machine translation. We inform ourselves and experiment on many low resource methodologies. And finally, the step from going from the models into a useful way that these tools actually help the translators. And especially in many cases, these are non-professional translators, because it's really hard to source translators in many of these marginalized languages. So let's start with our efforts in language data collection. So just to define the problem out there, we have listed in here a group of dominant languages of the world, together with the languages of our focus, Gamayun's focus. On the left-hand side, you will see the number of parallel sentences available in the Opus collection. I'm sure most of you are familiar with. It's a repository of publicly available parallel data. And on the right side, you see the number of native speakers of these languages. The breach you see is drastic here. Well, for example, just as a comparison, French and Hausa have more or less similar number of speakers, but while French having 200 million parallel sentences available, Hausa only staying at 400,000. This is not a minority language. This is language spoken by a lot of people, and the disadvantage is incredible, as you can see. You see also in the case of Dutch having 24 million speakers, really close to the speakers of Congolese Swahili. And while Dutch has 75 million sentences available, Swahili having only 600,000. So this is a really, really important topic, not just in NLP, but also, as you say, we're speaking from the humanitarian perspective here. So in context of data, the first impact point we are having is we create data, and we call these Gamayun kits. This is like, a kit just to start working on a language. We are creating parallel text data, also recording audio data for speech-related applications. Our starting point is basically different sets of data of sizes of sentences, 5,000, 10,000, 15,000, 30,000 sentences, all having unique set of sentences, general domain sentences in English, Spanish, and French, which are like the pivot languages when you're translating into these languages, into many of these languages. And what we do is we translated these into the languages we focus on. Right now, we have translated mini kits, 5,000 sentences into Hausa, Kanuri, Rohingya, Swahili, and Nande, which are available through Gamayun portal. And among these, for example, Kanuri and Nande and Rohingya, these 5,000 sentences are basically the first parallel text corpora out there. So this was general domain. When we're dealing with a COVID pandemic and you're going to make machine translation and so on, it's not enough general domain data. In order to make COVID-19 domain data, we have partnered with George Mason University, Carnegie Mellon University, Johns Hopkins, Google, Microsoft, Facebook, Amazon translated an app to make a really extensive data set in COVID-19 domain to first help build machine translation models, evaluate machine translation models in COVID domain, and also to assist translators through TMXs, like translation memories. So this data is also available through the TICO19 portal. So what next? Now let's speak about actual development. Among these languages, we initially focused on 3 through our partnerships, through the necessities, and through the urgency of the language. These are Levantine Arabic, Tigrinya, and Congolese Swahili. So using data out there, using our data coming from our translations and the data that we create, we apply a couple of different techniques according to our needs, which are domain adaptation, dialect adaptation, cross-lingual transfer learning, and back translation to make synthetic parallel data. So I'm going to illustrate really briefly what we did. First, for Levantine Arabic, this is the first project we have carried, which was a partnership with World Food Programme, where the necessity was to monitor the behavior, the complaints and comments of Syrian refugees residing in Jordan. These refugees are basically socializing and speaking about their environment in the web pages, in the Facebook page of Cabrona, which are called Cabrona, and in order to monitor these, we need a machine translation model. So what we did is we collected 5,000 sentences from these pages and translated them into English. So this data set is small but really important. Why? Because it's in the Syrian dialect of Arabic. There are basically very few data sets available for Syrian dialect. Second, they're colloquial language. They're basically speaking, in a social media environment, which changes a lot the language. And finally, they're speaking about their life in the refugee camp, the food that is provided to them, the electricity, and how can they do their paperwork and so on. It's really specific domain. So small data, but important. So what we did is we basically built a base model using modern standard Arabic data out there. Thankfully, there is a lot, and adapted into this domain. So in order to assess the usability of this model, we have first evaluated with Blue our domain adapted model performing like more than 3% better than the general Google machine translation engine. So showing how important actually could be domain adaptation in this context. And also we saw that the error rates in terms of accuracy and fluency are acceptable, between 1 and 1.5 in a scale of 3, from minor errors, okay, to major errors. We saw that actually our system could be useful. It's not performing incredibly well. I mean, looking at the Blue scores, but in terms of, for example, monitoring in a large scale, the behavior and the status of refugees, this is actually a usable benchmark. So next comes Tigrinya, which is recently very relevant because of the armed crisis in the Tigray region of Ethiopia. This is it's a language spoken by 7.9 million people. It's a Semitic language. written with the Gaze alphabet you see here. And it's also, it is very relevant because it's a refugee language in Europe and USA. So there's a lot of translations actually performed by Translators Without Borders in order to make information reach to these refugees. It's also one of the hardest to resource translate language in Translators Without Borders. There are on average 3 active translators, and some of the translations are not claimed. And also there's like an average 72 days of delay between a task is introduced and when it's claimed. So a low resource language, not much out there. So what we did here is cross-lingual transfer learning using also low resource but higher resource close relative Amharic, which also uses the same alphabet. So through this technique of cross-lingual transfer learning, we were able to achieve kind of an increase in translation quality when translating from Tigrinya to English. We have first built a multilingual model, then adapted to Tigrinya, and then adapted to our humanitarian domain translations. Through following a step like this, we were able to achieve, compared to a unilingual model, we were able to achieve 23.6% below score. So this was on Tigrinya to English. However, just to share, even though we haven't really continued the work there, but in English to Tigrinya direction, we are nowhere close to what we have achieved. In other way, seeing about 10% below, which really calls, first of all, shows like this cross-lingual methodologies work in favor of Anglo-centric or like English or high resource language direction. When you're working the other way around, you don't have much to do other than basically using the data out there. And if it's less, then you're, and especially with a language like morphologically rich language like Tigrinya, the task becomes much more complicated. So anyway, you can read more about our work in our paper presented in the Africa NLP workshop last year. I mean, no, this year, sorry. So finally, Congolese Swahili. This is the Swahili dialect spoken in Democratic Republic of Congo. It's one of the languages in this country. The colonial language is French in this country, but not everyone, of course, speaks. The dissemination of information is really important because of the conflicts there. This is a language spoken by 9 million people. That's actually, I mean, that's and Swahili is a language that actually is in some commercial MT provider services. However, this is a dialect which actually differs a lot from the Congolese, from the coastal dialect in terms of vocabulary, grammar, and structure. So what we did is dialect adaptation using all the data available in Swahili, but adapting into Congolese and adapting into our domain. And discovering that there are monolingual corpora available in coastal dialect, we have created synthetic data, translating these with our models to French, and then using this in our experiments. And we were able to see 1.3% bleu score increase in Swahili to French direction, reaching 27.9 points. And in French to Swahili direction, again, showing the difference 22 point blows. So this was about basically creating machine translation models. So what are we planning to do with these? Are these usable? How can they assist our translators? In this aspect, we are collaborating with Microsoft Research India in deploying their interactive machine translation framework for our languages. So what is interactive machine translation? This is an alternative to post-editing interface for translators. So instead of basically having a sentence and delivering its translation and then editing it while you're doing the translation, there's a constant collaboration between the translator and the machine translation engine. The translator is presented with, as you would see in this case, with the source sentence to translate, and constantly the model is suggesting and giving hints on how to do the translation. If you like it, you just press one button and it's basically written. And if you don't, you type in whatever you want, however you want the translation to go, and the model adapts from there and gives you suggestions from what you write. So they report that there's a faster translation process when this is used, which we want to experiment with our languages. And also what's really interesting is like this is a good way to leverage low resource models. So a model that is performing suboptimally, but I mean it's delivering something. With human input, with constant human input, you can actually make it much more useful. So for example, in this below score table, compared to partial input from the translator, you see for a language with 100,000 parallel, 100,000 word corpus, Telugu and English, in the low row, you would see 12% blue can increase to 42% blue with the input of the translator. So this is very promising in terms of low resource translation when the aim is to actually help the translators. And we see this is promising, firstly, to help the translators, and also it could be useful in order to augment data, helping crowdsourced parallel data collection, kind of a more fun and faster experience. We hope to report on this soon. So that was about it. I basically tried to summarize our ways of our working areas. We deal with a lot of low resource languages, and we're looking for impact. We're doing this basically to get life-saving information to the people speaking these languages, and I hope it inspired you, researchers of low resource languages. And any questions, suggestions, connections, and everything, I am totally open. Either through your questions coming right now or after the workshop, through email or however you want it to be. Thanks a lot.